So this afternoon we have 3 talks, 1 talk about networking and 2 about orchestration. And we'll start with networking with a talk which is a sequel to a talk that was given in Austin and which was basically how do overlay networks work. This will be a deeper dive in Docker overlay networks by the person who brought to us deep dive in overlay networks, Laurent Bernay from D2SI. Sorry, it's super hard to say like French acronyms in English. That should be Lars against that. Please, a round of applause for Laurent.
Hello. Okay, hello everyone. My name is Laurent Bernay. And yes, I'm going to give a talk on overlay networks, and it's a follow-up on the one I gave in Austin. So out of curiosity, can you raise your hands if you were in Austin and saw my talk? Okay, only a few people. And this is going to be a lot about networking. So I wonder how many of you are familiar with network equipment and BGP at least? Okay, much more. Nice. Okay. So don't worry for those of you who didn't make my talk in Austin. I'm going to do a quick summary at the beginning. So here is what we're going to talk about. So the first thing I'm going to talk about is do a quick reminder of how the Docker overlay works. And then we'll talk about the VXLAN control plane option, so how it works, how you can distribute information, VXLAN information in Docker. And then we try and use BGP as a dynamic control plane. I say try because all the talk is going to be a demo, so I hope the demo gods are going to be with us. And at the end, we'll show a few use cases that we can do with this kind of setup. So I'm going to start with a quick reminder on the Docker overlay. So when you build a Swarm cluster, you can create an overlay network with the command I gave at the top. And so in this example, I just created a DockerCon overlay. And if you connect to another host in the Swarm cluster, you can see information about this network. So this information is shared between all nodes. And what's interesting is if you start a container on one host, you can ping in from a container on another host using this overlay network. So the way it works is this. So I'm not going to go deep into this, but I'm going to quickly explain you. So basically, when you create an overlay, Docker is going to create a namespace, so there's the red square in the middle. And then it's going to create a bridge and a VXLAN interface. And when you create a container, it's going to be attached to the bridge. And when you extend traffic between nodes, you're going to use a VXLAN. So at the bottom of the slide, you can see an example of a VXLAN frame. And so the original L2 frame, as seen from the containers, is the black box, okay? And VXLAN is basically an additional header around this original L2 frame. And so as you can see, you have several pieces of information, the IP address of the physical host to tunnel traffic, a UDP header with ports, and then you have a VXLAN identifier, which allows you to have different overlay between nodes. So what is VXLAN? As I just said before, VXLAN is a tuning technology of a UDP. It was developed by a cloud provider to provide multi-tenancy in big OpenStack network at the beginning. It's pretty easy to encrypt if you want, because since it's standard IP traffic, you can just put IPsec policies between hosts, and your VXLAN traffic is going to be encrypted. And it's important to know that you have a slight overhead because you have the VXLAN header, and it's exactly 50 bytes. Which doesn't really matter if you have big packets, but if you have many small packets, it can have an impact on performances. So in Linux at the beginning, there was no native implementation, so most people were using Open vSwitch. But now since kernel 3.7, it's native in the kernel, and it even comes with namespace support since kernel 3.16. So let's start with the demo part. So what I'm going to do now is I'm going to show you how we can create an overlay manually with standard Linux commands. And the way I'm going to do it is I'm going to start with these 2 hosts, okay, Docker 1 and Docker 0, and I'm going to try and build an overlay between them. So what we're going to build first is we're going to build the equivalent of what I showed before in the Docker overlay, which is this overlay namespace where you have the VXLAN interface and a bridge. So to do this, I give you the command there. I'm not going to spend too much time on it. If you want detail, all the slides are going to be available. But basically what I'm going to do is I'm going to create a namespace. I'm going to create a bridge in that namespace and give it an IP address. And then I'm going to create a VXLAN interface in that namespace and connect it to the bridge. Okay? So since all these commands are kind of big, I'm going to use a script, but this script is basically doing exactly what I showed. So let's go to the demo. So I'm going to do the exact command I showed you, but with a script. Okay? So here this command is going to create a VXLAN interface with VXLAN ID 42. This is the 42. The namespace is going to be called over NS. And then we have different VXLAN options. And I'm not going to go deep into it, but if you have questions afterwards, we can discuss it. So I'm going to do it on the first machine and now on the second one. Okay? So both machines have this over the namespace created. So let's go back to the slides. Now that we have this core part of the network, what we're going to do is we're going to create containers and attach them to this. So I'm going to create a C0 container on one host and a C1 container on the other host. I'm going to give both containers IP addresses and connect them to the bridge. So once again, I'm not going to go into details into the commands, but what's important is what's in orange on the slide. So I'm going to create a container without any network, so not the -- net equals none. Then I'm going to grab the network namespace from this container, and then I'm going to create a vHet interface, which is basically an Ethernet pipe, and one hand is going to be inside the container, and the other end is going to be inside the overlay namespace I created and attached to the bridge. Okay? So I'm going to do that for both the containers on Docker 1 and Docker 0, and as you can see at the bottom of the slides, I'm going to give these containers IP addresses and MAC addresses so they can ping each other. So let's do that. So first, I'm going to create a container that does nothing. It's basically only sleeping, okay? And I'm going to do the same on the other one. Okay, and instead of using the commands I showed you before, I'm going to use a script. So just to show you that I used net equals known, we can see inside the container that there's no link. There's only the loopback. And now I'm going to use a script that does what I showed you on the slides before to avoid typing all the commands. So here I'm using a Plum script that I wrote, and that's available on GitHub. And basically what I'm telling it is create a pipe between the demo container and the interface BR42 in the overlay over NS. And then there's a configuration for IP address and MAC address. So let's do that. Okay. And I'm going to do the same on the second container with the other IP address. So the first one is in .10 and this one is in .20. Okay, so now the question is, does it ping? Okay, so let's try and see. Okay, so first of all, what we can do is we can see that now we have an IP address inside the container. Okay, I've got this ETH interface, and if I look at the IP address, I can see this the IP address I just configured. So what we're going to do now is try pinging. So from the host in .10, I'm going to try and ping the host in .20 on the second host. Okay, it's not pinging. And the reason it's not pinging is because this container has no clue where the other container is. It has no ARP information, and it doesn't know where to forward the traffic. So if we look inside the container, we can see that there's absolutely no ARP information. So using the neighbor command, I'm showing that it doesn't have any clue where the other IP is. So what I'm going to do now is I'm going to manually create this. So I'm just going to go back to the slides because it's going to be easier to read. Okay, so it didn't ping. And what I'm going to do is I'm going to populate the ARP information to the neighbor database. So it's aligned with IP neighbor add. When I'm telling on Docker 0, at the container on Docker 0, where the container is, what the MAC address is for IP20. And then I'm going to say, okay, this MAC address is located on another VXLAN host, and the IP address of this VXLAN host is 10.0.1.10. Okay, and of course I need to do the same on the second container because it needs to find the first one. So let's do that. So these commands are kind of big, but they are not very complicated. So let's do this. Okay. Okay, so I just put the information that was missing before. As I can see now, you have this ARP information database. And what I'm going to do is I'm going to do the same on the second container. Okay, so this one you have the IP and MAC address of the container on the first host. So now, if the demo gods are with us, we should be able to ping. So let's see. Okay, it's pinging. So here is what we built. So what's added from the first slide is now we have this RIP and forwarding database information, which allows us to find the host where the container is located. But you see, it's very manual, and there's no way you can scale this kind of thing. So you have different ways to distribute addresses in VXLAN, and I'm going to go through them now. So the first thing you can do is you can use multicast. So you can use a multicast group, and all the hosts in the overlay are going to connect to this multicast group. And when you need information, you're going to send traffic on this multicast group, and you can get the information back. So this is very simple, but I think this multicast is not always easy to use because it's not available in most cloud providers, and multicast skills are not easy to come by. Another option that's even simpler is what you can tell the VXLAN interface to send all unknown traffic to a remote IP address. So this is even simpler. It's very good if you have only 2 hosts and you just want to do a very simple tunnel like GRE, for instance, but using VXLAN. But of course, it's very difficult to manage if you have many hosts. The third option is very different. What you're doing is basically you tell VXLAN not to do anything, and this is what I did in my demo. And what you do is you're going to provide all this information using a userland daemon. So in this example, you see that the daemon is responsible for populating ARP information and forwarding database information. So this is very flexible, but the thing is it requires a daemon, and it requires you to write software to do that. The reason I spent a little more time on this one is because it's how it works in the Docker overlay. So as you can see on the slide, I added the Docker daemon and a key value store on the top. And basically what the Docker overlay does is it uses gossip to exchange information between Docker hosts. And what's happened is when you create a container on one host, the Docker daemon is going to send this information to all containers in the VXLAN setup using gossip. And all the other daemons are going to get this information and populate their RP and FDB data. Okay, I know that was a lot of information. So this is what I did in Austin was a full talk on what I just showed now. So everything is available, the slides, video, and I wrote a blog post on it. And this is an excerpt from the video. So don't hesitate to check it out if you want more information on these topics. So now we're going to get to the heart of what I wanted to present today, which is how we can use another way to distribute information, which is we're going to use BGP. Okay, so it's a fourth option, and in that case, you have a daemon that's responsible for exchanging information between nodes and populating all VXLAN information. But this daemon is going to be a standard daemon. It's going to be a BGP daemon. Okay. And it's usually BGP is used to send IP prefixes. In our case, we're going to use an extension of BGP called EVPN, which is used to set up VXLAN networks. Okay, so what's nice is BGP is a standard way to distribute address. It's proven to scale, and it's supported by most network vendors. The limitation is today the implementation under Linux are very limited. The one I'm going to use is a fork from Quagga called Cumulus Quagga, made by the Cumulus network team. It works fine, but it's very new, but I'm pretty sure that in the future it's going to be implemented in FR routing or BERT probably. So I saw a few hands when I asked questions regarding networks, but I still want everyone to know what it is. So BGP in one slide, it's kind of a challenge, but I'm just want to give you an idea of how it works. So BGP is a routing protocol that's used to route traffic between network entities, which are called autonomous systems in BGP. And an autonomous system has a number. So for instance, big telcos, big cloud providers like Amazon or AWS have one or more AS numbers, and these autonomous systems are connected with BGP. So BGP is an external gateway protocol, and for many people, usually routing is interior gateway protocol, so the one you see on your LANs or MANs, and you may be familiar with protocols like OSPF or EIGRP. So in an IGP, the next hop is the IP of the next router you're going to use. And in BGP is slightly different. The next hop is simply the next autonomous system you're going to go to. So what I said before is, well, BGP scales very well, and it's what makes the internet work. And when I say it scales, I mean today we have more than 500,000 IP prefixes, and even small providers have a full internet table, and they manage these prefixes with small equipment. So we're pretty sure that we will be able to manage hundreds of thousands of containers using BGP. It should be okay. So I talked about autonomous systems. So to give you an idea, imagine here we have these 5 autonomous systems connected together. And in autonomous system 1, we send the prefix, we have the prefix 20, and we're telling everyone we have it. So AS2 and AS4 are learning this information, and they are propagating it downstream. And from the point of view of AS3, we have 2 routes to this 20 prefix. And as you can see, this paths in BGP are only the list of autonomous systems you're going to use. And so you can say we have 2 paths. One is going through AS5, AS4, AS1, and the other is AS2 and AS1. And BGP is going to use by default the shortest path, so it's going to use the AS2, AS1 path. And what's important is it's regardless of the complexity of the network. Physically it could be a lot faster to go through AS5 and AS4, but from a BGP perspective, it's just going to use this. And on all this, I wanted to present 2 different versions of BGP. So the classic one, the one most people know, is eBGP, which is the connection between 2 different autonomous systems. So it's for external BGP. And what's important is within an autonomous system, you also need to get this information around, and you use a small variant of BGP, which is iBGP for internal BGP. And I wanted to say that because today we're going to talk about iBGP only, because we're going to have a single autonomous system. So in iBGP, you need, when you have several routers doing iBGP, you need them to get information from all the other ones. And it used to require a full mesh between all peers. So you can see how it can get tricky if you have dozens of iBGP hosts, because you can imagine the number of connections you need to set up. So a good way to solve this was introduced, and it's called route reflectors. And basically what happens is you connect all your iBGP routers to these reflectors, and when the reflectors learn an address from one router, it's going to send it to all the other. So it's much simpler and much more scalable, and it's possible to have more than one for scalability or resiliency. As mentioned before that we're not going to use BGP for IP prefixes today. We're going to use BGP with EVPN. So with BGP, you can announce IP prefixes, but you can also announce different class of address, and this is what's called multi-protocol BGP. And in our case, what we're going to do is we're going to announce VXLAN information, and you have 2 types of prefixes. So the L3 information is going to be the address of all the VXLAN endpoints, which are called VTEP in VXLAN words. So it's VXLAN tunnel endpoints, and also the location of MAC addresses. And what's interesting with this is we will be able to send unknown traffic to all the hosts, because we have the list of all the hosts in the network. And what's interesting, as I said it before, is you get the scalability of BGP. Okay, so let's go back to the slides. You remember how host Docker 0 and Docker 1. So what I'm going to do now is I'm going to connect them to 2 route reflectors. Okay, and I'm going to be using Quagga, which is a Linux implementation of BGP. Okay, so let's do that. So first of all, I need to clean what I did before. Okay, so I'm going to delete the containers and overlay namespace. I'm doing it on both hosts. Okay. And now what I'm going to do is I'm going to do this. So I'm going to start a container running Quagga on both Docker nodes. Okay. And you have the command there. It's not very important. Something you can note is I need to run it with privilege flag, because Quagga is going to modify the routing table and forwarding information in the kernel, so it needs to be privileged. And I gave you the main part of the BGP configuration on both route reflectors and the BGP client, the Docker hosts. And what's important is on both, so it's in blue. I don't know if it's, it's in blue. It's that I'm not going to advertise any IPv4 for prefixes, because I'm only interested in in EVPN, sorry. And what's in red is the connection between BGP routers. So on route reflectors, I'm just going to say I'm just going to tell the router to listen to any connection from my AWS VPC in 10.0/16. And on all the all the Docker hosts, I'm going to point to the route reflectors. So that's why there's the IP address there. And the last part of the configuration is I'm going to enable EVPN. So on both route reflectors and Docker hosts, so they can exchange EVPN information. So let's go back to the demo. I'm going to start the command I just showed you. So I'm going to start Quagga on both nodes, okay? And now that Quagga is started, what we can do is we can access the Quagga shell. So I'm going to exec into the Quagga container and run a command called vtysh. And it's basically the shell, the Quagga shell, which allows you to interact with the router. So if you're familiar with Unix shell and how they're pretty similar between different kind of Unixes, network shells are very similar between equipment vendors. And for instance, the Quagga shell is very similar to the Cisco shell called iOS. So if you use it, you should be familiar with the command I'm going to type. Okay, so now I'm in the shell, so I can first show you what's the configuration that's running. And you can see here that basically it's the configuration I showed you on the slide before, okay? And what's interesting is I can show you the BGP neighbors, okay? So it's pretty long, but what's important, you can see from the first line is we're connected to the neighbor in 05, okay? And somewhere below, we should have the connection to 15, okay? You have it in the middle of the slide. Okay, so my Quagga container is connected to both route reflectors. What I want to know now is, well, what kind of EVPN information do I have? What kind of EVPN neighbors do I have in my setup? So from the Docker host perspective, I have two EVPN neighbors, which are the two route reflectors. Okay, and also what I want to do is I want to see if I've learned any EVPN routes from these reflectors. Okay, so I'm sending this command. And now there's not any route, okay, because my hosts are connected, but there's no VXLAN endpoint, so there's no route to be learned. Okay, so this is what we built. Okay, so we connected Quagga on both containers to the route reflectors. We looked at the BGP data, so this is what I just showed you. And what we're going to do now is we're going to configure the VXLAN interface. So it's going to be announced by BGP. So you remember before when I created the overlay namespace, what I did is I used the setup VXLAN script. And I'm going to use it again. It's going to be very similar, but instead of creating an overlay namespace, what I'm going to do is I'm going to use the Quagga namespace, okay? And I'm going to create the bridge and the VXLAN interface in this namespace. And there's another option that's slightly different. It's no learning. So basically, the VXLAN interface can learn traffic from the packets it sees. But what we want to do is we want only to learn through BGP. Okay, so we don't want anything to be learned dynamically. We want it to be controlled by BGP. So I'm going to do that. Okay, so create these these interfaces. Okay. Okay, this is not going to work in the Quagga shell. Okay, it's done on those. So I'm going to connect back to the Quagga shell, and we should see a few more things. So now we should have some EVPN routes. So let's type this, so show BGP-EVPN route. Okay, and we can see that so I'm on Docker 0, and we can see that now I've got information on a host called 1.10, which you can see here. Okay, there. And this is the other Docker host, which has also a VXLAN endpoint. And so this is from BGP, and we can now look at the EVPN configuration itself. So we can see that we have one VNI, so one VXLAN network. And what we can show here, what we can see here, sorry, is that we have a remote endpoint. Okay, so it's 1.10. So we only have information regarding all the endpoints connected, but now we have no containers, nothing running, so we have no MAC address, and we can verify this with this command, okay, to see all the MAC addresses in my VXLAN network. Okay, so there's no MAC addresses yet. So what I'm going to do now is I'm going to, okay, this we did, is we're going to create two new containers, and we're going to connect them to the bridge I created, okay? So the plum command is very similar to the one I used before. I'm going to connect this container to the bridge, and I'm going to give the same IP address and same MAC addresses as I did before, but this time it's going to be distributed dynamically. I also added a default gateway, which we're going to use a little later. Okay, so let's do that. So I'm created a container without network and connecting it to the bridge. Okay, so this is on the first host. And I need to do it on the second one, okay, with the .20 IP address, okay. So now that we have this, we can go back into the Quagga shell, and we should see some MAC addresses. Let's see if it works. OK. So now this information, the containers I've created have appeared in BGP, and they have been propagated to my host. And you can see, for instance, on Docker 0, I can see that I've got a local MAC address, which is this one, the one from the container I just created. And on the remote host, I've got this other MAC address. OK, so with this, now we should be able to ping. So let's verify this. OK, so I'm using the same command as before. OK, it worked again. Good. OK. OK, so this is what we did. This is the BGP information I showed you. This is the overview. So what we did compared to before is we still used VXLAN for the data plane, so for actual frames, but we use BGP as a control plane this time. So what's interesting with this setup is, well, we use a standard VXLAN address distribution, which means we can connect our network to any router that's able to do VXLAN and BGP-EVPN. We have full management of BUM traffic, which is like broadcast and node and multicast traffic, which means we can do ARP queries, we can do broadcast or multicast. And I don't know if you've noticed, but if you use a standard network overlay, you can't do that. You can't do multicast and you can't do broadcast, which means you can't do DHCP, for instance. So of course, BUM traffic is not very efficient because all multicast and broadcast traffic is going to be unicasted to all hosts. But there are many optimizations in the VXLAN world. So on all routers, it's enabled, and it's going to come to, it's available in Cumulus Quagga, and it's probably going to come in all implementation. So now that we've done this, we can do many things. So the first thing we're going to do is we're going to create a second overlay, okay? Because we've created one. That's interesting. But what we want to do when we have overlays is to have different overlays and have them isolated. So what I'm going to do is I'm going to do exactly what I did before. So I'm going to create a VXLAN interface inside my Quagga container namespace. And I'm going to create two new containers called demo66 inside of demo, and connect them to the bridge and give them MAC address slightly different with 66 where there was 0 before. So let's do that. OK, so the first command is going to create this new overlay. OK, here we go. And now I'm going to create the container and attach them to the new bridge. OK. Oh, sorry. OK. So I used this command to, sorry, it's hard from here. So I use this command to create the VXLAN interface, this one to create a container without network, and now I'm going to connect the new container to the bridge. OK, and I'm going to do the same on the second host. OK, let's go. OK, and this time we should be able, from the container on the first host, to ping the second one. OK, so now we're pinging the container on the second overlay. And what's interesting is, of course, I shouldn't be able to ping the container on the first one. OK, so it's not working. There's no route, and it doesn't know anything about it. If we go back to the Quagga shell, what's interesting now is we're going to have much more information. So as you can see now, we've got information regarding the first VXLAN. OK, here, if I can select it. OK, and then here you've got the one with the second VXLAN, the one we just created. OK. OK, so we did just this. Something we can do now is, since we have broadcast, we can actually do DHCP, which is something that's interesting because you could connect your container to an existing DHCP network or setup. So what I'm going to do now is I'm going to create two new containers. The first one is called DHCP, so it's the one on Docker 0 with the orange bar around it. And then I'm going to start a new container without any IP configuration and get its IP configuration from the container running DHCP. So the way we're going to do it is we're going to start a container with a standard DHCP image, and we're going to attach it to our network. Okay? And then we're going to start another container. But what's important, I'm just going to try and see. Yes, it's a DHCP there in orange, where I used to have an IP address. And so now it should get DHCP information from the DHCP server. And just to give you an idea, this is a DHCP configuration I'm using, so it's pretty simple. I'm just I'm telling it to use range starting at 0.100. So let's start our DHCP container. Okay. Let's let's do that. Okay, here we go. Okay, I'm just... Sorry. There's something I need to know there. I need to connect it very quickly, otherwise the DHCP daemon is going to go out because it needs an interface to bind to. And so now we're going to look at the logs of the DHCP containers. Okay. So the DHCP server started, okay, and it's waiting for DHCP requests. So what I'm going to do now is I'm going to create a new container on host 1, okay? So without any network, it's going to be called demo DHCP. And then I'm going to try and get an address using DHCP, okay? So I'm connected it to the bridge, and then I'm telling it, use DHCP to get an address, and I'm not going to give it to it. So let's try, okay? So as you can see on the logs from the DHCP server, we got the request, and we gave the container an IP address. And so we can verify it, because now if I do this, so the container is called demo DHCP, we can see its IP address. It should be 100, okay, the one we got here. Okay, so it got it from DHCP. And since now this container is connected to our network, so it should be able to ping the other one. So let's see. Okay, so it's pinging the first one we created. Okay. So far, we've been working in a full container environment. What we're going to do now is going to be pretty interesting. We're going to bridge this container world to the outside world, which is where there's no container running, okay? So what we're going to do is we're going to take another machine, okay? I'm going to connect to it. I'm going to create a VXLAN interface and a bridge and attach an interface to it. And from this machine, I should be able to ping the container because all this information is going to be exchanged with BGP because I've got Quagga running on the host. And it's going to be channeled using VXLAN. So what's interesting is I can bridge between the Docker world and outside of the Docker world, okay? And you might be surprised why I give the IP address to this V8 interface here. It's because you can't give an IP address to a VXLAN interface. It's probably going to come in the future. I know it requires a few things in the kernel. And it works if you give an IP address to the bridge, but I've had weird behaviors with the way BGP-EVPN works. With this configuration, it works perfectly fine. I mean, hopefully, we'll see. So I'm going to connect. So I'm going to go out from this, and I'm going to connect to a new machine. So it's .20, okay? So this machine is gateway, and there is absolutely no Docker installed, okay? And there's no specific configuration in there. So what I'm going to do is I'm going to create the VXLAN interface, okay? So what I just showed you. And then we're going to need, and then I need to create the V8 interface. So I'm just going to do it, and I'm going to show you on the slides what I did. So it's a few commands. It's kind of big. I'm going to explain it. It's not very complicated, but okay. So let's go there. So what I did, I created the VXLAN interface and the bridge. And then what I needed to do is I need to create a V8 interface to connect to it. So as you can see from the slides, a V8 interface has two hands. So one is connected to the bridge, and the other one is going to remain in the namespace, not connected to anything, but I'm going to give it the IP address with .1, okay? And so now that we've done this, we should be able, from this machine where there are no containers, we should be able to ping the machine, one of the containers. So let's see if that works. So 10, okay, it's working, great. Okay. So now we've got out of our Docker environment, but what we've done is it requires having a VXLAN interface, a bridge, and Quagga on the host. So it's nice, but what if we want to access the outside world where there's nothing regarding Quagga or VXLAN? So what we're going to do now is we're actually going to connect to a host that has no information, no BGP information at all, no VXLAN information at all. So what we're going to do is we're going to enable routing on this machine I used before, the gateway machine, and we should be able from this machine to route traffic between containers and non-Quagga or VXLAN hosts. And what's interesting too is I can do it for all the machines inside the VPC. but we could also access the internet using NAT on the host. So this is what we're going to do now. Is basically I'm going to enable routing on the gateway machine. I'm going to do the NAT configuration. So say, okay, everything that's not sent to the VPC, NAT it when it's coming from VXLAN. And then we're going to see if from the demo DHCP container we created before, we can actually ping machines that are totally outside of the world of containers and VXLAN. So let's see if that works. Okay, so I need to do this. Okay. So the first command is going to enable routing, and the second one is going to enable NAT. And now, if I go there, and I should be able, so I'm still able to ping the gateway, okay? But I should also be able to ping this machine in 30. So this is a totally separate machine where there's nothing whatsoever. Okay, and I'm able to ping this machine. What we can also do now is we can connect to this machine and verify that there's no NAT. So let's do that. So I'm going to SSH to the machine in 30. So on this one, I can show you. I mean, there's no bridge, no VXLAN, nothing in there. Okay, no Docker even. Okay, but I should still be able to ping my containers without any NAT. So let's see if that works. Okay, that works. Okay, so we're almost done. One of the things I wanted to show you is, well, a fun thing we can do is, since we have a bridge and machine, we can create a virtual machine there, and you can imagine that the host here is some VMware or big KVM host. And I can actually start a VM and connect it to the bridge, and it should be able to get its IP address from a DHCP container and be able to access everything we did. So what I'm going to do now is I'm going to start this VM. So let's do that. Okay, so I don't know if you're familiar with QEMU. QEMU requires a tap interface to connect and not a VAT interface because it was done quite a long time ago. Okay, so I need to connect to the gateway machine. Okay, so here I'm creating a tap interface. I'm going to attach it to the bridge and bring it up. And what I'm going to do now is I'm going to start a QEMU VM, okay? And what I'm going to do is I'm going to actually start a Linux Kit VM, okay? And I'm going to tell it to use the tab 0 interface I just created. So if that works, okay, I should have done it on the other machine. Let me fix, let's do, because I want to see the logs from DHCP server. So let's do this. And I'm going to do it from here. Okay. Okay, so I'm looking at the logs of my DHCP server, and now I'm going to start my VM. Okay, so it's going to take a few seconds for the VM to boot, but when it's booted, it should make a DHCP query on the bridge. This query should go through the VXLAN network and get to my DHCPD server, which is going to offer it an IP address. Okay, maybe like 10, 20 more seconds. Okay, so we're in Linux Kits. Okay, and as you can see on the DHCP server, I saw the query, and so and now, of course, on my VM, I can connect to any host. So I should be able to ping this one, for instance. Okay, I know what's happening here. Okay, so it works. So. So the reason it took a while is because you need the BGP information to be forwarded between hosts. So sometimes when you create a machine and it appears in the VXLAN network, it's going to be picked up, distributed by BGP, and it's going to populate the information on the target host. So sometimes it takes a little while. Okay, so that's good news. Okay, and we're almost done for today. So what I wanted to show you is this setup is full VM, but you could imagine a world where you have containers running on dedicated hosts, and then you could bridge to the actual network. So you could use standard Juniper equipment as route reflectors because it's standard, and you could bridge with your actual physical network using another brand like Cisco. And so basically, you would be able to have a flat network using routing between Docker and standard regular host on your network without any NAT. So I wanted to do a very quick comparison to other solutions. Since I'm kind of late, I'm not going to do it, but you have an idea here. So basically, most solutions use VXLAN as data plane, and they use an implementation of gossip or a variant of an implementation of gossip to exchange traffic, to exchange information. And they require daemon a lot of things. What's interesting in what I showed you is, well, you just need to have a BGP daemon on the machine, and it's very standard. So this is all very new. I've had many issues with the implementation I use from Quagga, but it works. So, but I think in the future it's going to work a lot better. And I'm pretty sure that also there are many questions regarding performances that need to be addressed, because VXLAN is great in terms of features, but still in terms of performances it can have an impact. And I'd like to work on a CNI plugin so I could do a demo with a full Kubernetes cluster, for instance. And that's it. So all the things I did today are available on GitHub. Okay. So if you have any question, I'm not sure we'll have time for maybe one question or two, but you can ping me on Twitter or come and see me just after the talk or later today. No problem.
Thanks a lot, Laurent. I had high hopes for this talk, and I was not disappointed. And I hope it was the same for you. Yeah, for questions, we won't do like the big Q&A like that. However, Laurent is not going anywhere, so you can come and ask your questions directly. This is the usual. Remember, please rate talks in the app to indicate the things you liked, the things you didn't like. This was the last networking talk for this track. The next two talks are going to be about orchestration. Thank you.